Hey, hello to all. My name is Pavlo, and today I will cover with you all topics included in this webinar. So we will talk about uh, steel frame checking according to Eurocode standards. I hope all participants already connected, and we can start our today's session. So, a few words about me. My name is Pavlo Zadorozhnyi. I am a technical lead at engineering department of SDC Verifier. With more than 10 years experience in mechanical design verification. Mainly, I specialized in serving industries such as heavy lift and offshore structures and other spheres which are close to this. So, uh, first of all, I would like to start from an agenda. So uh, I would like briefly explain what topics I plan to cover today. So I will start from introduction. I will explain main goals of the engineer, which shall be solved or discovered during the frame checking. Also, we'll add few words about our company and our workflow. Next, I will go briefly through the model which I prepare for this presentation and which I will use to show you how to work and how to check it according to Eurocode standards. Next one, we will go to load combination. So this I will show how easily you can create this combination with uh, according to Eurocode rules. Next step, I would like to show you some static stress results, which further we will compare with results of check. And after that, all next topics, I will explain how to do a frame checking according to different Eurocode standards. So mainly we will go through the Eurocode member check and Eurocode joint check. And also, in case of any question, I propose to write it on a chat. And in the end of this webinars, I will give an answer on it. So let's start. As you all know, metal frame for industrial building or for civil building is a very complex structure, which consists with a lot of joints and structural members. So in general, for such construction, use it standard rolled shapes, so like I shapes, or as you can see from this example, or some L shapes or C shapes, which connected together with bolted joints. So this is some example of bolted joints, or bolted joints with combined with some welds, and mainly on such construction has effect and some permanent loads such as oven weight. In case of industrial building, also you will have some dead weight from the heavy equipment, and also more very important load is variable loads such as wind load, snow load, and so on. And the main goal is, in this case, is to check global strength of the frame and local strength of the frame. You should check all joints, which take into account all loads affected to our structure, to our frame. I see that somebody cannot see his screen on my side, or everything is fine. Okay, I think we can continue. Okay. To avoid such a failures as a global backlog, so as you can see from this example, and to avoid some problem with the joints, because when you had some problems with the joint, in the end it can collapse a full structure. So in some cases, it can be very real challenge when you have hundreds or even thousands of members and joints on your structure, and all of this should be checked. Also, you had like hundreds of combination which you need to take into account and to analyze, influence each of it on your model. So all this can take a lot of time. And as a solution for this, which will help you to speed up this process, I would like to propose to all of you our software. So this is SDC Verifier. So it will help you to speed up this process, to recognize all members, to group all these elements on your model, to recognize uh, to recognize all joins, which basically will speed up your process of checking the structure, and you will never miss something, some critical areas on your model. And I will show you during this webinar how with our software we can perform this checking of this steel frame in a few steps. So I would like to start a few. I would like to start from a few words about our software and our company. So our company was founded in 1998 by our CEO Walter van der Bos. Company starts as an engineering company, which gives structural engineering consultancy. Our CEO Walter van der Bos understands that some of process during the FIA analysis and during the reporting can be optimized, and this can speed up a process of and this can speed up process of finalizing your project calculations and so on. And from this period starts history of SDC Verifier software. So now our company grows up to 30 plus people. Our soft uses more than 1,000 happy users, and with our software, we continue to give engineers consultancy to help our clients to solve their problems. So here you can see some of our clients. So we made more than 250 completed projects, and number of our clients grows from year to year. So here you can see some of our regular clients with which we work along the years. And next step, I would like to explain you some workflow, how works our software. So our software has like two options. So you can use our standalone version, which allows you to work independently without any other software. And second option, it is like add-on to such program as ANSYS, FIMAP, or SimCenter 3D. But for all of this, for all these two options, we have the same workflow. So first of all, you start from simulation. So you prepare your FIA model, you apply to this model some FIA loads, then you analyze it, and you have some basic results for this model. Second step, it is load combination, because when you need to check something according to some rules, according to some standards, it requires to prepare some load combination prescribed these rules, which take into account some factors, some partial safety factors, some dynamic factors, and so on. So this can be easily created in our software. Next step, it is recognition. So recognition helps to recognize structural members, joins, which will be used further in the checks. Because all you know that FEM model, it is a set of elements, but to perform a check, for example, beam check, you need to recognize this member in the firm model to get proper length, to get some other parameters. Same, for example, if you want to perform weld strength check, so you need to recognize all elements on your model, which basically will be used further in a weld strength check. And all of this you can do automatically with SDC Verifier recognition tool. And after that, next step is checking. So you can select one of standard from our library of standard in SDC Verifier and perform a check of your structure according to these rules. And last step, SDC also help you to prepare some documentation. So we can prepare our model description report, which will include explanation of brief explanation of your model setup, such as properties, materials used in model, some fan loads applied, some boundary condition, and so on. Or you can prepare a result report, which will include some uh, basic results which you receive during the calculation. And also, additionally, you can use our structural optimization tool, which basically will help you to optimize your structure without remodeling this model. So SDC will automatically check your shapes and optimize these shapes, or optimize some material properties, or so on. So according to our workflow, one of the steps it is recognition, and for this, SDC can propose like four different recognition tools, which help you to recognize on your model some structural elements which further can be used in the checks. So first one it is joint and connection finder. So it helps to find all joint and connection on your 1D model. So as example, you can see the simple 1D model, and with red color highlighted all joints, which was automatically recognized by SDC on this model. Then these joints will be used in the beam member finder or in joint checks. To perform some check in the beam member finder, joints will be used, and it will help to determine beam lengths and also buckling lengths, because depends on this joint types can be different buckling lengths for some member. Next one it is beam member finder. So it does help us to recognize beam members on such a frame structure. So in our case, for example, in case of frame checking, here you need to recognize all members and some members in your structure to determine all lengths in all direction, which will be used in the buckling check. It is really important part of structure checking. And these tools will speed up process of this of structure checking, because it really fast recognize all members on your model. Next one it is Weld Finder tool. So it helps to automatically to recognize all welds on your model. So it works with 2D elements, with plate elements. So you can see here some example how looks. So highlighted with light blue color elements was recognized as welds in this model. And this also I will show today during the weld strength check, but also this can be used in a fatigue check, because for fatigue check it is important to set proper notch classes. And with Weld Finder, it is not even recognizes weld, but also automatically converts stresses in this element in the proper direction for further proper setup for notch classes, which depends on the stress direction in the weld. And last recognition tool, it is Panel Finder. So Panel Finder helps automatically to recognize all section plates and stiffness for plate buckling check. So plate buckling check according to some DNV rules, according to some Eurocode. So this will not cover it during this webinar, but here you can see an example of part of ship hull, and with different colors showing all plates, which was automatically recognized on that part. So we already had a lot of standards implemented in SDC. Here you can see only some part of this list, and we always works on adding additional standards to our library to grow our library, and also we always open to add some new standards requested by our users. And as I mentioned before, so we had the standalone version. Basically, that's how looks this standalone version of SDC. So in that case, you can prepare your FIA model, analyze it with using SimCenter and Strand solver, and then use all possibility of SDC to check this model without any additional program. So you will have only one file which will already include a model SDC project, and you can work with it and prepare all your documentation and so on. So that's how basically how look Windows is SDC. So here you can see some FIA model. From left side you can see model tree explanation. So all fem loads apply to model, all constraints, explanation of your job, individual load sets, and all required information about your model. So now let's go to model explanation. So for this example, I will use a simple model of steel frame. So this is part of some industrial building. Model in general created with 1D elements, as you can see. So this is simple rolled shapes. So in general, this is I shapes or C shapes. Also, here at this part, I create some detailed model with plate elements, 2D shell elements, which are connected with 1D element bolts. I will use these detailed models for bolt check. So we will check this for bolt according to Eurocode rules, and also to make this connection. So you had like rolled I-beam, which should be connected with bolts. You need to weld here some plate on top of this I-beam, and I will use this to show you how to do weld strength check according to Eurocode rules. So to model already applied all loads. So here you can see few of them. So we take into account open weight of structure. So we also apply some loads from dead weight of equipment. So this is some local influence. Also, we take into account some platform dead loads. So it is like distributed forces. And also we would like to take into account wind load in two directions. So this is wind load in X direction and in Y direction. Also use a simple type of constraint. So I just simply fixed it from the bottom. It basically simulates connection with anchor bolts. So nothing special. So this is a simple fixed constraint. So at this step, basically, yeah, we are done with model. We had model. We applied to this model forces. We had some boundary condition. And next step, what we need to do, and it is very important, we need to prepare some load combination according to standards. And SDC Verifier basically gives you two options. So how we can create this load combination. First one, it's shown here. So it based on some hand calculation. So you can prepare some table with load combination directly with in SDC. So you just select under model tree load sets, select create, edit multiple, and you will see table with list with your of your individual loads. So we see that I had 11 individual loads in my model, and I combined it in total in 16 load sets. And here you can read in a row what this is the title of our load combination, and this is all individual loads which I include into my load combination with the factors which will be used, which will be multiplied to this individual load. So basically, load combination, this is linear combination of our individual load. Individual load, it is combination of firm load plus boundary condition. And so this linear combination will show us total influence all of this load in our structure with proper load combination. You can easily work with this table. So you can or create this matrix with factors directly here in SDC, or you can prepare your matrix with factors in Excel, where you can link all your cells with some equation. And further, for example, if you need to change some factor, some dynamic factor, some partial safety factor, you can automatically update it in Excel, then select all these factors, copy and paste to this table, press OK, and it will automatically create new load sets. Or if you already created, it will update already existing with the proper load factors. So this is the first way how you can work with load combination. And the second one, it is with using predefined load cases. At the current time, we had only this will work only with two standards, with Eurocode standard and with YAN standard. So in this case, you should select predefined load cases, and after that, you will see this window. And what you need to do, you will see a list of all your individual loads, where you need to select a proper category for this individual loads according to this table which prescribe it in the standard. You already can see her partial safety factor, and if you need, you can also add some dynamic factors to each of these individual loads and press OK. And after that will be automatically created all load combinations according to all of these tables with a proper partial safety factor, and with taking into account some additional factors or dynamic factors which you will type here. So this is two ways how you can create a load combination in SDC. And after that, next step, what we recommend to do, so we recommend to combine all the load sets into load group. So what is load group? Load group will show you worst results, highest results from all loads or load combination which you include in this group. So this will help you to see, for example, in one plot, all worst results and find all critical zones on your model. So we will use load groups to show all our check results and so on, because this helps us to not miss any critical zones. So a load group, it is like an envelope combination. It is shows you all worst results from all items included in this load group. In our case, we will use load group envelope load sets. This automatically created load group, and this load group, as you can see, already included all our load combination, which was created on the previous step. So we're done with all this preparation, and let's check some stress results. So model was already analyzed. I prepare load combination, and I just try to check my stress results on load group. And so as you can see from this, stress level is not so high. So assume that we use seal as S235, all stresses is below yield limit, but this plot and results of stresses do not give us an answer if our structure is safe, because well, you know that, for example, buckling can occur in some members even when stress is less than yield limit. And to receive an answer on if our structure is safe enough, we should do some checks according to standard rules. And for this, we will refer to two standards. So I will use during this webinar this two Eurocode standards. First one, it is Eurocode 3 part 1.1, which help us to check in general our structure. It will help us to check all cross sections, and also what is most important is we can check all our members on buckling. And second one, it is Eurocode 3 part 1.8. This is design of joints. This will help us to check a bit more in details our joints. So we will check bolted connection, which I show you, which I modeled in detail, and also we will check welds in there at this connection. So we will perform weld strength check. And we will start from global check-in. So this is Eurocode 3 part 1.1.1. So this is beam member check. And to do this, first of all, we need to recognize all members in our model. And to do this quickly, we can go to recognition tools and select from a list of recognition tools beam member finder. After that, you will see the main window of beam member finder. Here you can see some settings, but in most cases you don't need to change nothing here because you can use all settings, default settings. What you need to do, you need to press button find, and SDC start automatically analyze and recognize all members and some members on your model. After SDC finish it, you will see here a list of your members, as you can see now on my screen. So I already recognize all members, and what is important, you can see that we recognize lengths of each of this member in a different plane. So we had lengths in Y, lengths in Z, lengths in torsion direction. So this direction and this axis, it is not a global axis, it is a local, this is axis of local coordinate system of element. So after that, when I recognize all these members, yeah, I would like to plot, to show you these elements, how it looks, and also it will help us to check if everything was recognized well. And for this, we can select, press button, plot selection. So I plot it with different color, and that basically how it looks, how look all my members, which was recognized in the model. So we see here with a different color showing all members, which was recognized in model, and parameters of which, so lengths, buckling lengths, will be used in the buckling check in the member check. And as you remember, I showed you that we had different lengths in the different planes. So it is really important part of buckling check because, for example, one beam member can have two different lengths, depends on the plane. For example, you see that the same member in the Y direction has two submembers, two smaller submembers, because it has this support or this beam in this plane, which basically divided into two smaller ones. But if you will look on it in the Z direction, you see that in vertical direction, you do not have any supports here. That's why in that case, for buckling check in that plane, we will use full length of this member. So SDC does this automatically, and you see that it automatically recognizes different lengths in different planes. Also, each of these members can be added manually. So you see that we had a tab with edit member, and you can or hide or select from a full list some member which you are interested in, or you can, by pressing this button, select one element on member, and it will automatically show you here this member. And from this picture, you can see that you can see like full length of this member and on which nodes it divided. And for each of this sub member, you can see length which was recognized by SDC. This shown for different planes, so for LY, LZ, and also for torsion. All these lengths you can edit manually. For example, if you want to remove some node, so you would like to check what will be if buckling length will be taken account from this node to this node, you just simply unselect this node. So this is node 1345. You go to this node and select it in that direction, and in that case will be taken into account full length from this node to this node in check. So yeah, all this editable, and you can easily edit all these parameters of each members which was already recognized in your model. We are finally recognized all our members, and the next step is to add standards to add standards to our project and to define some parameters of the standard. So to do this, you go to standards in the model tree. So select press right mouse, click on it, and select from list the required standard. In our case, we start from member check, so we should select Eurocode 3 members. And after that, you will see window with standard settings. So we call this like standard wizard window. And here you can see some parameters which you should define, and some parameters which already define it as default. For example, all these factors, this is default value. It is refers to standard, so you can easily find it in standard. And also for each of this standard, for each of this window, when you open it or when you press F1, you will directly redirect to our help page of SDC, where you can find explanation for all of these parameters, and with reference to standard, why you need to define and where we're taking this value. So this parameters is default, but as you can see, you still can edit it. You can type here your own values, or you can leave it by default. The next one, you should define some parameters of your member. So this is like some fabrication type. It will have influence on the results. So fabrication type, it means you should select or it rolled beam member, or it welded. So some manufactured methods, or it hot finish it, or it cold finish it. In some cases, when you simplify your model and prepare your cross section without taking into account fillets on your model, you can edit it here. So by typing a value of your fillets, and it will be taken into account when cross section will be checking. Also, same for section net area, because when you model everything with 1D elements, in some cases it is hard to take into account some holes for the some holes for the bolts. So this will reduce cross section area, and yeah, you can take this into account here by defining the proper value. And also, last parameter, this is material type. It is required because on it depends buckling curves which will be used in the calculation. Also, this is correction factor, so it depends on how moment this depends on moment distribution. So it refers to table 6.6. You have here two options, or you can calculate it according to this table, or you can go with easiest way and just set it one for all moments. So this will be like in worst case. Next one, it is method how will be calculated lateral torsional buckling. So you had two options, one according to chapter 6322 and another 6323. And last option, you can calculate both of them and then present results for worst of this tool. Another option which you can select here is what lengths for torsional, fractional, and lateral torsion buckling should be used. So you can use it or from LY, L and LZ direction, or you can use lengths from beam member find. And the last option, so it is how will be calculated asymmetric shape. So since now in our in current version of Eurocode member, we cannot calculate some asymmetric shapes. You can select these options and it will be calculated as a symmetric. And another one option, it is calculate or cross section of class 4 as a cross section as class 3 because yeah, we cannot calculate now this class 4 because this class 4 it is depends on stress distribution on your cross section, and we it is hard to calculate this and to get to this class 4. So we give an option you can calculate this is like class 3. Otherwise SDC will not show results for these members because yeah we do not support class 4. So after we define here all these parameters, you can press OK. And also one more thing. So if you, for example, forget to recognize members using Beam Member Finder, you also can go to Beam Member Finder directly from this window of standard wizard. So by pressing this button, it will open window with Beam Member Finder, and you can recognize all members and then go back to this window and set up all parameters. So when you press OK, under your standards, you will see that you will have added one standard. So it is Eurocode 3 member. And when you go, when you open the standard, you will see a list of checks. So all these checks, it is so this is a list of check which you can find, which basically you can find in the standard, and each of these checks you can easily edit. So, for example, if you select this eggshell check, press right mouse click on it, select edit, you will see this window with check where you can find all formulas or all equation which use it in this check. So with reference to all equation in the standard. So everything is clear, so we do not hide anything. Also, we given you an option to edit these checks, so you can convert the standard into a custom and easily edit it, added your own formulas or update some formulas already included in the standard, and then use it in your for your calculation. So when we add the standards, next step, what we would like to see, we would like to run our check. And to do this, you need simple select. So I always start with plotting my results. And for this, I select last check in case of this Eurocode member check, because you see that we had a lot of check included in this standard. So it is shear check, axial check, bending check, buckling compression, buckling torsion, and so on. And this last one check, so this is buckling, and overall, it will show us the highest values of utilization factor from all this check above. So I would like to look on the contour plot. And after I select contour plot, you will see the window where you can set some parameters for your plot. So I use I use here parameter utilization factor overall, and I would like to look on this results for a load group with all load sets included. And after pressing this button preview, SDC will start to analyze check. And after that, you will see how looks this results of beam member check. And as you remember, so stress level was really less than yield. But when you look on this beam member check, you can see that we had some overstressed members. Not overstressed, but some members with utilization factor higher than one. So all our checks presented results presented with the value of utilization factor. So all values which is higher than one, it means that it doesn't pass the check according to standard rules. And when I see this, my next step is, I would like to post-process somehow these results. I would like to know what is real value here. So how much is bigger than one, and also I would like to know maybe what law has an influence on this result, biggest influence on this result. And to do this, we can use our SDC post-processing tool. So this is Peak Finder. So it will help us to check do not so it will help us do not miss any overstressed parts of your model, and also it will help us to find out what load combination causes this problem mainly, and to check all critical zones. So I add this peak finder. I set here some parameters. So I will check based on overall utilization factor. I would like to see all parameters, all zones with values of utilization factor higher than one. And after I press OK, I will see this table. So this table basically shows me all zones with on our model with utilization factor higher than one, and load, which has the biggest influence on these zones. And also, I can make a plot for this. I can show this. I can visualize this. So if you go to the next slide, you will see. So that's how this results looks in a general plot of member check, and then I plot it from peak finder, and you see that we had at this middle part we had utilization factor 1.16. So also this part overstressed, and also we had some values for this, so it is 1.68. So with this peak finder tool, you can easily find all overstressed zones in your model, even if you had some really big model with some hidden parts which you cannot see on the full view. But with this peak finder, it will highlight to you all problem zones. Another way how to check results, it is results. You can check all your results in the table. For this, you need to select the same check, but instead of selection contour plot or criteria plot, you should select table. And after that, you will see this window. You just need to press fill table, and it will fill in this table with all results for each of members. So here you can see ID of BIM member, and here you can see value of all utilization factors. So you see that overall utilization factor, it is maximum from all of this, it is 1.52. And also you can check in details how this calculates. So when you, for example, select first member from this list, you will see that this button will activate. So this is detailed results. And when you press it, you will see this window. And this window basically shows you step-by-step calculation with all values, how this values was calculated, based on which numbers calculated. So it also really helps you to understand and to find out why you have these results, because of what numbers and what characteristic you had this result. So yeah, it helps to figure out your problem. So we are done with Eurocode member check, and next one it is Eurocode bolt check. So we don't need to recognize any bolts here. So we just need to select proper elements which we need to check as a bolt. So we immediately can start with adding our standard. So we should select the proper standard from a list. In our case, this Eurocode 3 bolt. And after that, we will see the window with some standard settings which you need to define. So first of all, you see it is more parameters than you see than it was for Beam Member Finder, but it because that we cannot automatically recognize all of this parameter for bolted connection, and that's why you need to define it manually. So first of all, this is some constant. This value is according to table 2.1. So this is some default value. You don't need to change it because it is directly refers to standard. Next one, you need to define some parameters, so some end distances and edge distances and spacings for your bolted connection. It will have influence on your results, and it is basically refers to this figures from standard. Also, you need to define some hole type, so to determine values of factor Ks, and also class of friction. All other parameters, it is parameters which refers to some bolt dimension. But for example, this position of the bolt in the direction of load, you should define which bolt is like end bolts or inner bolts. The same for position of the bolts perpendicular. So we need to define which bolts are end bolts and which bolts are inner bolts. So yeah, bolt class. So this is parameter of bolt which will be used in a per load calculation. Some hole diameter. Also, you need to define some bolt thread pitch, which we cannot measure from the simple 1D element, some countersink bolt, if it countersink or not, thickness of countersink, and so on. So this is simple parameters and dimension of bolts. So when you define all these parameters, you can press OK, and you will see that one more standards added to your standard list. So it is Eurocode Bolt 3. And when you go to checks, here you can see slightly less number of checks. So all these checks grouped according to this table 3.2. So this is categories of different bolted connection, depends on some loading and checks which you need to do. So this is some bearing type, slip resistance, non-preloaded, preloaded bolts, or so on. And also each of this check you can edit. So select one of them, press edit, and you will see the window with all formulas, with all equations, with reference to standard. You can easily find it in standard, so you can convert this to custom check and update manually. So edit our formulas, edit your own formulas, and use it in your calculation. So, and when we done with this, we can plot our results. So first of all, I start with plots. So I would like to check my bolts on slip resistance and serviceability for preloaded bolt. So I select this check. I select criteria plot. I select my load group. Select these 4 bolts and just press preview. And after that, SDC start to analyze this standard, and that's how look results. Yeah, results looks not so high. Yeah, you see that all stresses is less than 0. Not stresses, all utilization factor is less than 0.2. But as you remember, even stress level at this zones was really low. So this results is reasonable. So we do not have any problem with this bolt and with this bolted connection in general. So next step, we also can check this with the table results. So in the same way as we do for plots, we just select the same check, select from list table, select all these bolts, press fill in, and here you can see all utilization factors calculated in this check. And you see that really all factors is less than 0.2. Yeah, one of them is 0.23. And also, you can check all details how it was calculated in the SDC. So you select one of this item from table, press this button, detailed results, and here you can see all equations with all values, how it calculates step by step with end results for this current bolt. At this step, we end up with bolt check. And uh, last check, which I would like to show you today, it is weld strength check. For this one check, we need to refer to our recognition tool because we need to recognize elements which basically will be calculated as a weld in this check. To do this, we need to go to recognition tools, select from list of recognition tools weld finder, and after that you will see the main window of weld finder. Also, as in the case with BIM member finder, you will see here some settings. In most cases, you can leave it by default, just press button find, and it automatically starts to recognize all welds in your model. So recognition time depends on size of your model, but even on a big model, based on our experience, some model with more than 1 million elements, it takes less than 5 minutes. So yeah, it is really works fast. When you press this find, when SDC will finish with recognition, you will see here a list of welds. In my case, I have only 5 welds because yeah, this is a simple model and it is explainable. I have 1 weld, second weld, third weld, fourth weld, and 5 welds. And I would like to plot this weld because LSDC also has an option to recognize what part is welded and not welded. So let's plot this. And you see that here with different colors, you can see that that yellow one, it is non-welded part, and blue one recognizes as a welded. It basically depends on the thicknesses of welded parts and on some geometry. And next step, after we recognize elements which will be calculated as a weld, next step, it is for weld strengths, we need to define what weld type it is. Because program do not know what weld type should be used here. And for this, you need to go to weld strength settings tab. And here you will see a list of your 5 welds. And here you can apply to this weld some weld type. In my case, I just apply simple double fillet weld by selecting this option. And to apply throat thickness of this weld, I use a simple rule. So I set that throat thickness should be equal T divided by 2. So in this case, SDC will take thickness of this welded part and divide it by 2 and will be used as a throat thickness of this weld. And after you apply this, you will see it's this table. So we apply to this weld type double fillet weld, and we apply to this weld our throat thickness, which is equal T divided by 2, because you see the thickness is 5.6 millimeter and throat thickness is 2.8. So this is 5.6 divided by 2. After that, we can press OK. We are done with weld finding with defining weld type parameter. And next step, it is to add standard. And as for previous standard, just select standards. From a list of standards, select required standard. So it is Eurocode 3 welds. And after that, you will see this window with standard settings. In case of weld strength check, it is simple standard. You do not have a lot of parameters here. What you need to define here, basically, it is correlation factor. It refers to table 4.1. It depends on your material type. Also, you can select calculation method. Or you can use summarize per weld part. So in that case, you will see one utilization factor per full length of weld, or you can show results for each element on this weld. A few more parameters, this what yield and tensile should be used. So it can be used or from weld finder tool or from material, or it can be used as a minimum from both of them. So material factor gamma it is default value. And also from this window, if you do not recognize it before all welds, you can go directly to weld strengths, to weld recognition tool. So when you are done with that, you press OK, and you will see here under standards that new standards is added. And as for previous standards, I would like to start with plotting some plots with results. And to do this, I select from this list of checks, last one, weld check, and add criteria plot, and plot these results. And results in case of weld sense check will be shown only for elements which was recognized as a weld. For all other, it will be not calculated because it is not a weld part. And yeah, as in case with bolts, for welds, we also not have any problem. So stress level there is really low. So it means that forces in this weld is also not so high, and that why stresses is less than 0.1. So utilization factor for this areas is less than 0.1. Next step, we also can check this in the table. So in the same way, we select last check. We select instead of plot table, we select all welds and just press fill table, and here you can see a list of welds with a utilization factor for all of these welds. And as for all previous calculation, you also can check some detailed calculation for this weld. So you select weld, you select detailed results, and you will see this window with step-by-step calculation with all welds. So when we are done with all our calculation, what we would like to do next, we would like to prepare some documentation, some reports, and for this you can use reporting in SDC Verifier. So just right mouse click on report, and you see that we had 4 different type of reports. So first one is empty. In this case, you will have like empty structure of your document, and you can add any paragraphs and chapters to the structure to this document by your own. Second one is predefined, so it is designing model setup. In this case, automatically will be created a document with some chapters and paragraphs which will describe your model setup. So it will be description of all materials used in the model, all cross-section properties, all FAM loads applied, all constraints, and so on. Third one, it is results. So it is also predefined report. In this case, for all of individual load combination and load group will be automatically added plot with stress, plot with displacement, and also table with stress, with maximum stress and maximum displacement, and you will have like a huge document with all these results. And designer full, this combination of model setup plus results. What also here you can see that I create this some document. So if since I create some plots and tables in the main window of SDC, I can import these plots to my standard. What I basically do, so you see that I import my results for Eurocode, bolts check for members, for Weld. So I had like few tables, one plot, and I can generate this report and then export it to Word, and that's basically how it will look. So you will have like first page and some tables with results. What is else useful, because all these structures, all these reports stored in SDC project, and if you need to change something in your model, so you need to update some forces, or you need to update some cross section and rerun this analysis, you calculate, you don't need to create one more time this document. You don't need to create one more time full structure of this document. You can just reanalyze your model, rerun all checks, then open this report which you already saved in the SDC, generate it one more time, and export to Word, and you will have exactly the same report, but already with updated results based on new incomes. So that's it about SDC. So as a conclusion, you can use SDC to speed up all your processes with via analysis. So you can use or standalone version of SDC, or you can use it like an add-on version of SDC to you can use it together with ANSYS, with VMAP, or with SimCenter 3D. It is possible if you will go to offer, you can request some trial license. You can try our program for free. And also, you can find some additional information about our program on our website, on our social media, such as YouTube. So there you can find some tutorials and some tips and tricks how to work with SDC. And for now, that's it. So if you have any question, you can write it, and I will check if somebody write some question, and we'll try to give an answer for this. Okay. I had some question from Chris. So with the beam buckling length, how does the software cope with different end condition, for example? So that's why I explained you different recognition tool, because first of all, SDC recognize all joints, and based on these joints, it is define different buckling length. So if you had fixed connection or joints which is treated as a fixed connection, it will calculate this buckling length based on this condition. If you had pinned it will calculate based on this condition. And also you had an option manually update this buckling length factor. So this all up to you. Yeah, so next question from Chris. Pinned versus fixed two members. Does the software take into account end condition automatically? Yeah, it should take automatically this condition. So all this condition of joints. So when you recognize all joints in model, it will be taken into account during the member recognition, and all these parameters will be taken into account when it will calculate this buckling length. That's why you have different buckling lengths for your Y direction, Z direction, and also for torsional buckling check. So next question is about EN 9099 1.3. I think it is not available, and I cannot confirm if we start to work on it or not, because we had at least a lot of the standard in the process, and it depends on the request from users. So more requests for some standards, we start to work on them. So it's hard for me to say for now. So if you have any other question, please type it. I still have some time, and I can give an answer on it. Okay, so if you do not have any question, I want to one more time remember that you can go to offers and you can request some trial license to try our software, and also you can find some additional information, some tutorials on our website. Some additional information also you can find from our YouTube channel, from LinkedIn, and you can find there how to work with our SDC. And one more question from Chris. Okay, for bolted connection, did you model the bolts or just the holes in the plate elements? I model bolts. So for bolt connection, for bolt check, you need to model bolts as 1D elements, because our check based on a line element force from this element. So we read axial forces, shear forces from this element, and after that we use it in to post processing in our standards for Weld check. Okay, guys, and that's it. Thank you for attendees, and yeah, have a nice day or evening to all.